Problem number 8. All right, so we start from two cylinders. So these two cylinders, they are identical. Now we cut along a vertical line, and then we glue them together into a larger cylinder. Now what we need to figure out is what is the ratio between the volume of the big one and the smaller one. So first, let's recall how we calculate the volume of a cylinder. So let's recall, so formula. Say I have a cylinder. Okay, so there are two parameters. One is the parameter R, and the other one, the radius R, and then we have the height. So then the volume equals pi R squared and times H. Okay, so let's see. So we start from, say this is the radius is R, right? And the radius of the bigger one becomes 2R because you have two circles, they go into one circle, and the parameter becomes twice. Now, of course, the radius becomes twice, right? All right, so the height is the same. So this is H, this is H, this is H. Okay, so then we can calculate the volume. So the volume of this is by the formula is pi times R squared times H. And the volume of this equals pi times 2R squared times H, which is 4 pi R squared H. So now if you compare these two, and we find it's 4 times of the smaller one, right? So the answer is D. Problem number 9 says, in my class, 60% of students only like skating, and the other 40% students only like skiing. Now, among those kids, we also have a certain percentage of boys and girls, and the question is, among all those girls, what's the percentage who like skating, right? Okay, so, well, we just apply the general formula to calculate the percentage. So percentage, according to the formula, which is a fraction, but except the denominator is 100, right? So which is the total number. So the denominator is the total number of girls. The numerator is the number of girls who likes skating. Likes skating, right? All right. Okay, we can assume, because here we don't know the number of kids in this class, you can either just introduce concrete number. It's not going to change the answer. It doesn't matter which number you use. Or to be more rigorous, we just use a variable. We say it's X, right? So I denote X as the total number of kids in the class, right? All right, so now I'm going to express the number of girls using X, and also the number of girls who likes skating using X. So here we have two sports, right? So let me mark them. The first one is skating. So here we have the skating. Here we have the skating. And also we have, this is skiing right here. And this is skiing. Okay, good. Now, then we can calculate what is the total number of girls? Because 60% likes skating. And then this is multiplied by X. Among skating, 20% are girls. So this is 20%. And then it's the plus. So this is from skating. Skating. And then you plus the portion of skiing. So that's what we have is 40%. And then among those 40%, 50% are girls. So that's what we have. So this is from skiing, right? Okay, from skiing. Okay, so now for the upper part, the number of likes skating, so that's exactly this part, right? So that's 60% times X times 20%. All right, so if we combine those information, we put into a fraction. So that's what we have. So 60% times X times 20%, and 60% times X times 20%, and then plus the skiing part, right? So 40% times X times 50%. Okay, Now we can simplify this. Now we can do some cancellation. Okay, so we can cancel those percentage signs. Okay, so then we can also cancel the x. All right, so what is left is 60 times 20 divided by 6 times 20 and plus 40 times 50. Okay, and this gives us is we can also cancel 0, 0, 0, which is 100, right? Cancel from the above and from the bottom. So what left is 12. 12 plus 20, which is 12 over 32. Okay, so this is divided by 4, so that's 3 over 8. Now we change this one to percentage, right? So you can calculate this is, this is 37.5%. Problem number 10. Here we have a triangle ABC. Angle A is 36 degree, angle B is 42 degree. Also, we have two isosceles triangle. First of all, we have AC equals AB, and then we have BC equals BD. That means both of them are isosceles triangles. So we know for isosceles triangle, if we have two equal sides, they are corresponding to two equal angles, right? Okay, then we have, because this one is 36, these two angles, they are the same, is easy to calculate. The angle is 72 degree. And also we have these two angles, they are the same, and this guy is 42. Okay, so we can calculate this, each one is 69, right? 69, okay, 69. All right, then we focus on this triangle CDE, right? We have this x plus 69 plus 72 is 180. And then we quickly get x is 39 degree, right? All right, so problem number 11. Here are two people, Alan and Ben. They climb a mountain. So Alan started first, 30 minutes earlier than Ben. But Ben is faster, so eventually they arrive at the top of the mountain at the same time. The question is, what is the height of the mountain? The quickest way to solve the problem is to introduce a variable x. We can x as the height of the mountain. And then according to the time they used, we set up an equation. Here is the graph. Here's the picture. So this is the mountain. Alan started 30 minutes earlier, so 30 minutes. And then go to the top of the mountain, right? Ben starts later, but they arrive at the mountain at the same, around the same time. Okay? So this is Alan, and this is the Ben. Now we denote x as the height of the mountain. Okay. All right. So then we get the time used by Alan is x over 10, because Alan's speed is 10 meters per minute. Right? X is in minutes, and time used, minutes, or we say minutes used by Ben is x over 15. The difference is 30 minutes, right? Because Alan starts 30 minutes early and they arrive at the top around the same time, right? So we quickly get the equation. So that's x over 10 minus x over 15, which is 30, okay? Now how we solve the equation? Well, we multiply 30 on both sides. That's because 30 is the common multiple of 10 and 15, and this helps us get rid of those denominators. All right, so we get 3x minus 2x equals 30 times 30, and this quickly leads to x equals 900 meters. Problem number 12. Here we have two numbers, 57 and 46. Okay, so they are divided by the same part of integer n. We have two remainders, one is x and the other one is y. And the only information what we have is x plus y equals 12. And we need to figure out, basically we need to figure out what is the n, right? Okay, now first let's write down those given conditions by simple mathematical formulas, or we say equations. So what I'll do is 57 when divided by m the remainder is x. Well, this notation usually means if you have two numbers, let's say here we have 57 and x on both sides, this notation usually means modulo n means they have the same remainders when they are divided by the number m, right? So here, the x is not only they have the same remainder, x is just the remainder. So we have the x, so x shall be less than n. Now the second one, 46 divided by the same m, the remainder is y. I also use this notation to represent that. Okay, now there's a very important property about the remainders. That is, remainders, they obey those standard arithmetic rules. So what I mean is the following. So from here, say I know 57, 46, they have the remainder x and y. Then this implies 57 plus 46, when they divide it by m, they will have the same remainder as x plus y, modulo n. So this is what I mean. It obeys the same arithmetic rule. Now you can also take the difference, right? 57 minus 46, it will have the same remainder as x minus y, and the 57 times 46 is going to have the same remainder as x times y, right? Okay. So here, as I put it here, so remainders obey those standard arithmetic rules. All right. Okay. So we have, and together this is 103 has the same remainder as 12 when it's divided by n. Okay. So now we are going to use the second simple but very useful thing about the remainder. If two things, they have the same remainder when divided by the same number, that means when you take the difference is divisible by that number. Well, this is understandable, right? If they have the same remainder, it just means when you divide by that number, they have the same left over. So if you take the difference, those left over, the same left over will be canceled. What is left is just multiple of the device, right? Okay, so precise speaking, so this implies, well, actually it's two directions, if and only if, right? So this implies 103 minus 12 is divisible by n. Okay, it's divisible by n. Now, what is 103 minus 12? This one is 91. So n has to be a factor of 91. So what we need to do is we need to factorize 91, right? So 91 is 7 times 13. Okay, so n cannot be 1, right? N cannot be 1. Okay, because otherwise we are going to get x plus y is 12. Okay, now, so we have two possibilities. We have, let's say we have case 1. So case 1, n is 7. If n is 7, let's calculate. So if n is 7, so what is the remainder when when 57 is divided by 7? We know 7, which is 2, because 7 times 8 is 56. It's 1, sorry, it's 1. So this is 1. What is 46 divided by 7? Modulo 7. That is 4, right? Because 4 times 6 is 42. Okay, so if it's 7, we get this is x and this is y. We get x plus y is 5, which is not 12, right? So that means this is case 1 is impossible. So let's look at the second case. So case 2. So case 2. How about n is 13, right? N is 13. Okay, so if it's 13, 57 divided by 13, what is the remainder? Is 5, right? It's 5. Now 46 divided by 13, what is the remainder? The remainder is 7. Okay, so here we have the x is 5 and y is 7. And let's check. So x plus y is 12, which is what we want, right? Okay, so then we combine those together, we get the n is 13, right? N is 13. Okay, so then we have m squared is 169. We add it together is the sum of digits is 16. So here the main point is, so this is the first important ingredient. So that is remainders, they obey those standard arithmetic rules. So this is number one. And number two is right here. So this is second key ingredient. It says if two numbers, when they are divided by the same number, they have the same remainder, which is equivalent to saying when you take the difference of the two numbers, the difference is divisible by the divisor. Okay, so we have these two key points and we combine together. What is left then just becomes a factorization of that difference, right? So we have two possibilities. M is either 7 or 13. One is clearly impossible. So look at 7 or 13 is not so sure at the beginning. So we have to check them separately, right? So after check them, we find, okay, so the one that works is 13. So M is 13. Problem number 13. The problem says A and B are two positive integers. We know the difference is 48. The greatest common divisor is 12, and the least common multiple is 252. Based on this information, we need to figure out A and B. More precisely is the sum, A plus B. All right, so we have two ways to solve the problem. The first one is kind of brute force, but not really. The second one will more based on algebra. Okay, so method one. Method one is no algebra. All right. So what do we have? So based on the GCD of AB is 12 and LCM of AB is 252, we immediately get A and B. Both of them are multiple of 12, and meanwhile, they are also divisors of 252. What we have is AB are multiples of 12, and AB are divisors of 252. So what we need to do is to look for those divisors of 252, which are also multiples of 12. And then from those possible candidates, we find A and B, right? So this is kind of brute force, but because here we already have some criteria, it's not so bad to use this kind of approach. All right, so we have 252, which is 12 times 21, right? Okay, then we find we are looking for divisors of 252, which are also multiples of 12. And we have, look at those divisors of 252, that 12 times 1, right? Okay, 12 times 3, 12 times 7, and 12 times 21. Now, these are possible candidates for A and B, right? What you determine is, okay, we look at those numbers and to figure out which two are what we want. At this point, we can use A minus B is 48, right? If you combine that, you say, okay, what we have is these two. So from here, we can get is these two. So we got A is 12 times 7, and B is 12 times 3. And you can check that's what we want. So this is a method. We don't use algebra. And here, it works okay, that because the numbers are not very large. So we can have, so you see here, we have only 4 possible candidates, and we just pick those two that will work for us, right? Now, let's look at method 2. We are going to use algebra. So we're going to use algebra. Right. Because you see A and B, they are both multiples of 12. I can write as A as 12 times n and B as 12 times n, okay? From here, we also have the GCD of m and n. It has to be 1. They cannot have a common divisor except 1. The reason is simple. So if m and n, they have a common divisor that's greater than 1, say 2, then this 2 can be contributed to 12, and we'll get, let's say, 24. It's going to be a common divisor of A and B, which is impossible because we already know that 12 is the GCD of AB. So this is just because the GCD of AB is 12, right? Okay, good. And then we have a minus b is 48. So what is a minus b? So it's 12n minus 12n. That is 12, right? So n minus n. So we get, okay, so n minus n is 4, right? n minus n is 4. And also, what is the LCN? Let's calculate what's the LCN. So LCN of AB, this is what we know, is 252. If I plug this into A is, so this is 12n, this is 12n. Okay, so we have LCN. I can put LCN, oops, I can LCN 12n. 12n is 252, right? Okay, now I can pull the 12 to the front. So I get 12 times LCN, n and n is 252. And I get LCN, n and n is 21. Now, because, so here's the point. So because the GCD of L and n, it's 1. That means L and n, they're relative prime. Now, if you have two relative prime numbers, the LCN is just the product, say like 3 and 4, right? So they are relative prime. So the GCD is 3 times 4, which is 12. Say, for example, like 5 and 6, right? So they are relative prime. So the LCM of 5 and 6 is 5 times 6, which is 30, right? Okay, so we have this one is just n times n. So if I combine, so this is n minus n is 4, n times n is 21. Okay, so we can quickly get, because again, the numbers, they are not very large, so we can quickly solve, guess this n is 7 and this n is 3, right? I can factorize 21 to get, I can do the factorization, right? 21, which I get is 3 and 7, I get the difference, right? Problem number 14. So this problem says we have a cube, and then we are looking for those vertices whose 3 vertices are from vertices of the cube, and that has an area of the square root 2 over 2. Okay, so first, let's figure out, like among all those triangles, what kind of triangle that has area of square root 2 over 2? Well, if you look at that, it's not that hard to figure out. The triangle should be like that, like this. It's a right triangle. One leg is 1, one leg is square root 2, and the hypotenuse is square root 3. So for example, so this is one of them, right? The hypotenuse is main diagonal, and or we use the same main diagonal. We can also have that. So this is another one, right? So if you look at the two triangles, one is the red and the other is green. Both of them have an area of square root 2 over 2. So we need to figure out the number of this kind of triangles. There are 2 ways to do. One way is kind of brute force. You just count one by one, and to find how many do we have, probably use some symmetry. The method I'm going to use is probably it's more efficient. So what do we do is let's focus on the hypotenuse, because the hypotenuse has to be a main diagonal. So here's the point. So the hypotenuse has to be a main diagonal, a main diagonal with a major diagonal. All right, so how many major diagonals do we have? We have 4, right? So step 1. So the number of major diagonal. Well, we know major diagonal, the length is the square root of 3, right? The number of major diagonals is 4, clearly. And then we figure out, after you fix a main diagonal, how many such kind of triangles can be formed? Use that one as a hypotenuse, right? So step 2. The number of such triangles associated with each major diagonal. Okay, all right. Now, let's look at this. So let's just focus on this one. So let's focus on this one. In order to have such kind of triangle, right, after the main diagonal fixed, we just need to determine the position of this leg with side length 1, right? So we just need to find, so we need to determine the leg of length 1, right? So then this triangle is completely identified. So let's fix on this main diagonal. Let's see how many choices do we have for this one? Because the length is 1, that means it has to be an edge of this cube, right? So it's okay. How many could we have? We have 1, 2, 3, right? So these are 3 choices. Or we can do is 1, 2, 3, right? So that means if I fix this mean diagonal, in total there are 6 choices for the leg of length 1, right? Okay, so the number equals 6, huh? Equals 6. So that's what we have. All right. So then we just combine them together. Okay, so we have 4 major diagonals. They can be used as the hypotenuse. And then as soon as I select this major diagonal, I'm going to determine how many triangles I can form, so which is equivalent to finding the leg with side length 1, right? So here we demonstrate there are 6 choices to set the leg of length 1. If you combine, therefore, you get the total is 4 times 6, that's 24.